Alright, this is just the Pixhawk with just motors. You can see the setup here. I'm not actually using a GPS, but that's the GPS, and that's, GPS. It's right here. Buzzer is right here. Power module is currently connected to the power supply at 12 volts, and then power for the motors is also coming from the power supply at 24 volts. This antenna is talking with this antenna, which is talking to the computer here. So you can see if I tilt the Pixhawk, I'm tilting it right now, that senses. I just dropped a screwdriver. That senses it. Not too important that there's errors right now because we're just testing the motors. So this is the more complicated or important part. The receiver, the X4R SB from FR Sky, has this SB pin, which is the bottom row, and that is going into RC in. This S bus is not the right one, it's RC in. And then this is channels 1 and 3 going to the motor controller and going to the motors. So you'll notice I have ground connected from the Pixhawk servo rail, which are those brown wires. Do not connect to power. Power is coming from the black and white wire. Sorry, the black and red wires up here. So you do not need these red wires. And then these signal wires over here are signal 1 and signal 2 from the servo rail. And this is the way it's oriented. You can see ground is on top, power is in the middle, which you're not using, and signals on the bottom. Alright, so now to see how it works, if I throttle up, it goes. I can throttle down. I can go left. I can go right. Which just doesn't make sense because it's not on a robot right now, but if it was on a robot, you can make it turn. And then if you are going if you put the joystick halfway and turn, one will turn slower than the other. If you go full throttle and turn, there's enough power that only one needs to turn. So there you go.